Okay, class, here we are, our Monday lesson. Just a real quick note to you guys. This week, I'm going to give you the lowdown. We are going to do the 4 lessons the first 4 days of the week. And like I did last week, I'll keep Fridays open and quiet. I'll do Friday's lesson on Thursday to give you guys plenty of time to review them and check them out. But I probably won't close that out until Sunday. I've had a little bit of a slow response to the Sunday closure thing from some of you guys. Are lacking a little bit of the dedication to get some of that stuff done a bit early. So make sure, if I'm going to wait till Sunday, make sure you get it done by Sunday so that way I can record the scores, because right now I'm not capable of doing that because I have several people that haven't. All right, so really quick, I want to talk about the chi-squared test. Right now we've done goodness of fit, and goodness of fit is one specific proportion distribution. One sample to compare to this distribution. Basically, the goodness of fit test gives you a bunch of percentages and then asks if the sample or the observed proportions match the given proportions. Independence is basically a two-way table that gives you 2 categories, and those categories are basically either dependent or independent on each other, and we can check the proportions to see if they're, and use the observed table, and then see if what we'd expect to see if they were independent, and then from there do our test. The last one is the test for homogeneity, or homogeneous test. Guys, this one is interesting because it's the exact same test as this. It is. So you're not going to learn anything new except for the wording. On this one, the null hypothesis, well, wait, I'll just show it to you. I have it all ready for you right here. So this would be an example of what the goodness of fit test looks like. Remember, we have a population distribution. Then we say at least one of these is different. That's the goodness of fit, null and alternative. This is what we said the independent test look like. This one is what you guys, some of you missed one question, and that's it, by the way, on those chi-squared questions on synergy. And some of you are like, well, what did I miss? How do I know what I missed? Guys, almost all of you missed the hypothesis for this, and I'll talk about that more tomorrow when we review the test for independence and dependence. Because remember, if we fail to reject this, we don't have evidence to show this. A lot of you said, I failed to reject this. That means I have evidence to show this. That's not true. If you fail to reject this, you don't have evidence to show this. But that's one of the weak spots we'll talk about more later. Last but not least, the test for homogeneity. Homogeneous chi-squared test for homogeneity. This is the one I believe you see a lot in your AP biology classes. Once again, that's one of the reasons why I'm covering all of these, is because I think it's important to see these chi-square tests, because they are the types of tests you'll actually probably do someday if you get into the medical field. Anyway, so basically here's what it says. It's the same thing as this, except it just words it in a different way. It says the proportion of individuals within each category are the same. So let me tell you what that means. That means that if they're independent of one another, that means the proportions for each independent category would be the same. So it's the same meaning, it's just different words. And then we would come back here and say that the proportion of individuals within each category are different. So it has almost the same feel as a goodness of fit. Let's take a look at what one of these would look like really quick. So I have this guy right here. I'm going to pause the video real quick. No, I'm not. I'm going to do the whole thing. Forget about it. So that way you guys can get a chance to see the whole thing again. I've got time. I just got to make sure I don't download too many gigabytes. Many colleges surveying graduation classes, survey graduating classes to determine the plans of the graduates. Random samples from 4 different major areas were taken, and their future plans were recorded. Do we have evidence to show that plans differ according to the major an individual chooses? Use a 5% significance level. See the wording here? Do we have evidence to show that the plans differ? It doesn't say independent relationship. We're not asking, is there a dependent relationship between this variable, whether or not you went to school, and what your interests are. That's not what we're asking, okay? We're asking is, do the proportions change from category to category? And once again, the exact same thing. So I'm going to pull up my calculator here, And I'm going to enter this. I have not entered this yet. I was planning on doing that and I forgot to, but that's okay, right? It's almost good for us to see this again. So it's a 3 by 3 matrix, right? So I'm entering this in matrix A. So I'm going to go ahead and enter these. 379, enter 305, enter 243, enter 125, enter. Oh, crud. Somebody should have told me. It's a 3 by 4. Yeah, oh well. I'll change it back. There we go. 125, enter 186, enter 238, 202, 96, 104, 123, 37, 58. And then I double check them real quick to make sure they look right. I believe they do. Yes, they do. Okay. I'm going to go ahead and run the test just real quick. Might as well, right? So second quit. I'm going to hit stat tests because it's asking a question. Do we have evidence of this? I'm going to head down here to the chi-squared test. There it is. I tell it my observed, what we observed in this sample right here is in A. When we calculate it, I want you to put the expected in B. I calculate, and there I have it. My chi-squared test statistic is 54.5. I have a p-value that's extremely small. It's obvious that I'm going to reject, right? Very obvious I'm going to reject. Okay, so didn't really even have to give you a significance level. Notice also the degrees of freedom. That's the number of rows minus 1 times the number of columns minus 1. How do we find that expected table? I'll share that with you in a minute. Okay, so what does our null and alternative hypothesis look like? There they are. We're going to notice how I do my introduction. I tell what type of test I'm going to do to see if there's a difference between the choices individuals make after graduation and the majors they choose. Students' post-graduation choices are distributed the same for all 4 majors. Students' post-graduation plans are different according to their major, right? So whether or not they employed, whether they went to grad school, whatever changed according to their interests or their majors. All right? We rejected, didn't we? So if we reject this, that means we have evidence to show students' post-graduation plans are different according to their major. All right? And that's the way the conclusion is going to look. Okay, so here we go. All right, here is our checks and assumptions, right? According to the problem, the samples were taken randomly, and all expected counts are greater than 5. Looking at all of them, they are. How do we find our expected table again? Let's go ahead and take a look at that again. Right? We find our expected table. Where did we put it? We put it in B, right? So I'm going to hit second matrix. I'm going to pull up B, and I'm going to take a look at it. And there it is. Notice 335.8. I can scan across, right? And I have all the values, and they are the same in my expected table. All right? So, and last but not least, a large number of graduates nationwide. So they're a large number, hopefully, right? We have a large number. All right? Boom. This is my equation. The expected table is my work. Actually, the observed and the expected table would be my work, but the observed table should have been given in the problem, and it would be, so you don't have to show it. There's my chi-squared statistic. My p-value is 0, 6 degrees of freedom. And last but not least, here we go. We come up with our conclusion. We reject the null hypothesis that the choices students make are the same according to their major. The probability of getting a chi-squared, excuse me, I just sneezed. And by the way, I covered my mouth, just to let you know, even though I'm by myself in the room. The probability of getting a chi-squared test statistic this big or bigger when the choices are proportionally the same is basically 0, much smaller than the significance level. I just tried to do a fancy p-value argument. We have evidence to show that individuals in different majors choose different paths after graduation. There's a sign of a conclusion. And that's pretty much it for chi-squared. I would have gone in a lot deeper, but considering this is more of a, hey, let's check this unit out, get ready for the exam type thing, and all of a sudden it's not on the exam, So now all of a sudden I've got to sit back and go, then why would I do it? Well, it is actually a pretty important test in statistics, I think, and it is part of the curriculum, and I think it's important that you saw it. Today's Synergy homework assignment, once again, we'll have 4 questions. You'll get 3 points for 4 questions. Should be quick and easy. Please try to get that done today because it goes into your next homework check. And the questions will be off of these notes and tonight's homework. Speaking of which, tonight's homework will be a chi-squared homogeneity worksheet that I have attached. Also, make sure you understand that after today, tomorrow, I'll go over a couple key mistakes you've made on those synergy assessments. Considering it's been a 96% average, there's not a lot of mistakes. Then I will upload the chi-squared quiz to give you guys an opportunity to take that chi-squared quiz and get free points, because there should be free points. You've already seen the questions. That will be uploaded sometime midday tomorrow. And then Wednesday and Thursday is going to be dedicated towards starting the review for the AP exam. So, good enough. Thanks, guys. Stay healthy, and good luck with this quarantine.